So welcome everyone for the session of Azure Big Data with Azure Data Lake Storage and Azure Data Factory. Myself is Navneet Sharma. I'm a Azure Data Engineer. I have around 13 years of experience in the Microsoft technology. I'm a Microsoft certified Azure Data Engineer Associate, and I'm passionate about big data and Microsoft Azure technologies. So in today's session, we are going to provide the introduction that why data is most important. We're going to discuss about the Azure data storage, Azure Data Factory, certification path, and what are the next steps that you can proceed with. Introduction. So let's talk about that. What is the importance of data? Data is the most critical asset as it's changing very frequently. We need to understand the importance of storing the data at the right place. Analytics on data is important because it helps businesses optimize their performance. Data helps in improving the business processes and it helps in making informed decision by performing the transformation as it moves from one system to another system. You can also optimize the cost by migrating the data from on-prem to Azure cloud. It provides the flexibility and scalability, and it also enhances the security and the simplified management and monitoring of the environment. So now let's begin with the data storage. First, we need to understand what type of data we are dealing with. Data comes in different shapes and sizes, and no single storage solution fits all data. Each dataset has different requirement, and it's your job to figure out which storage solution is best. The key factor to consider in deciding on the optimal storage solutions are first, classify your data, whether it's structured data, semi-structured, or unstructured. Structured data, commonly referred as a relational data, which follows the schema. The schema allows this type of data to be easily searched with the query languages such as SQL. Structured data is often stored in database tables with rows and columns with key columns to indicate how one row in a table relates to data in another row of the another table. Semi-structured data is less organized than structured data and is not stored in a relational format as the fields do not neatly fit into the tables, rows, and the columns. The example for semi-structure are the key value pairs. They are referred as a non-relational or NoSQL data. The common format for the semi-structured data are XML, JSON, or YAML. Unstructured data. Example of unstructured data includes media files such as photo, um, audios, videos, or any Office files such as Word document, text files, or log files. Once that you have identified what kind of data you are dealing with, the next step is to check how you are going to use your data. Some questions that you should be asked: what kind of operations you are going to perform and what is the performance requirement? Like how many code operations you need to require, how quickly you want to retrieve the data, and does it require complex analytical queries? And lastly, your application needs to group a series of data updates together because a change to one piece of information result in a change to another piece of data. Transaction enables you to group these updates so that if one event in a series of update fails, the entire series can be rolled back or undone. So now let's talk about the big data storage technologies in Azure. There are various services provided in Azure to store the data. Azure Storage is a managed storage services that is highly available, secure, durable, scalable, and redundant. Azure Storage is the most global storage solution Azure provides due to the number of services and the tools that can be used with it. Most flexible option for storing the blobs is Azure Blob Storage. Blobs are basically files. They can be pictures, videos, backup files, documents, pretty much that you can think about. Blobs are stored in a container, which are like folders. A storage account can have unlimited number of containers and can have unlimited number of blobs. Azure Data Lake Store. It is an enterprise-wide hyperscale repository for the big data analytic workloads. Data Lake enables you to capture data of any size, type, and ingestion speed in one single secure location for operational and the analytics purpose. This service is built on the top of blob storage, so you get the feature of hierarchical namespace, which helps to organize the objects and files into the hierarchy of directories. Data Lake Store doesn't impose any limits on account size, file size, or the amount of data that can be stored in the data lake. Both your blob storage and data lake store can be accessed from the Hadoop using the compatible REST APIs and can be accessed via the Azure Snaps using its Polybase feature. Both blob storage and the ADLS comes with three types of tier. Hot tier, which is the online tier optimal for storing the data that is accessed or modified frequently, and it has the highest storage cost but the lowest access cost. The next one is the cool tier. It's also an online tier which is optimized for storing the data that is accessed or modified infrequently. The data should be stored for a minimum of 30 days. It has lower storage cost but higher access cost as compared to the hot tier. The last one is the archive tier. It's an offline tier optimized for storing data that is rarely accessed. Data in archive tier should be stored for minimum of 180 days. NoSQL database. It covers the Azure Cosmos DB, which is Microsoft globally distributed multi-model database. Cosmos DB guarantees single-digit multi-second latencies at the 99th percentile anywhere in the world, offers multiple well-defined consistency models, and guarantees high availability with multi-homing capabilities. Azure Cosmos DB is a multi-model natively supporting document, key value graph, and commonly family data models. HBase for HG Insight. Apache HBase is an open source NoSQL database that is built on the Hadoop. HBase provides random access and storage and strong consistency for large amounts of unstructured and semi-structured data in a schemaless database. Data is stored in the rows of table and data within a row is grouped by a column family. Analytical database covers the Azure Data Explorer, which is a fast and fully managed data analytics service for real-time analysis on large volume of data streaming from application, website, IoT devices, and many more. You can use Data Explorer to collect, store, and analyze diverse data to improve products, enhance customer experience, monitor devices, and boost operations. We can also use Costo queries, which is a read-only request to read data and return result in the IO Data Explorer. The last one is the dedicated SQL pool, which is formerly known as the SQL Data Warehouse. It refers to the enterprise data warehousing features that are generally available with the Azure Snaps. So now let's talk about the storage redundancy. Redundancy ensures the data availability and durability in case of planned, unplanned events, including hardware failure, network or power outages, or any other natural disasters. So these are the redundancy options that are available for the storage account. LRS copies the data synchronously 3 times within the single data center in the primary region. It's the least expensive one and not suitable for the high availability applications. ZRS. It replicates the data synchronously across three Azure availability zones in the primary region. Each availability zone is a separate physical location and it provides high availability and Microsoft recommends to use for primary region. The next one is GRS and the GZRS. It provides a redundancy in the secondary region. GRS replicates 3 copies of data synchronously within the same data center using LRS and then copies your data synchronously to the secondary region. GZRS replicates 3 copies of data synchronously across 3 Azure availability zones using ZRS and then copies your data synchronously to a single physical location in the secondary region. And then in the secondary region, it uses the LRS to make 3 copies of synchronously within the secondary region. You have the read accessible version for GRS and the GZRS, which replicates your data to another physical location in the secondary region. However, the data is available to be read only if customer or Microsoft initiates a failover from primary to secondary region. When you enable read access to the secondary region, your data is available to be read at all the times, including in a situation where primary region becomes unavailable. So when So when we are talking about that the GRS and the GZRS provides the redundancy in the secondary region, it's always with the region pairs. So for example, that if you're creating your storage account in the East US, the copy will get be done at the West US, and if it's East US too, and then it's Central US, and so on. As the time passes, you want to move your blobs to the lower cost tiers. There comes the lifecycle management for storage account. Lifecycle management uses your rules to automatically move blobs to cooler tiers or to delete them. If you create multiple rules, the associated actions must be implemented in the tier order, like from hot to cool storage, and then to archive, and then the deletion. Rules are based on the last modified and the last accessed. You can also add filters that if you don't want to put or do want to apply the lifecycle management on all the blobs in your storage account. And you can also manage the lifecycle for snapshot and the versions. The last access option is only available if you enable the access time tracking. How we can secure your data in the storage account? So you can enable the soft delete for blobs and containers to recover the data that was deleted by mistake. You can provide a SaaS token to clients which should not be trusted with your storage account key, but whom you want to delegate access to certain storage account resources for a specified period of time. A SaaS token is a URI that grants restricted access rights to your storage resources. You can limit the access to your storage account to requests coming from the specified IP addresses, IP ranges, and subnet in a Azure VNet. You can also create private endpoints for your storage account and assign a private IP address from your VNet to the storage account, which secures all the traffic between your virtual network and the storage account over a private link. When public access is enabled, users with appropriate permissions can modify the container settings. Microsoft recommends to disallow the public access to the storage account unless you see the use case that require users to access the blob resources anonymously. Disabling the public access for storage account prevents the anonymous access to all the containers and blobs in that account. You can secure the transfer option by enhancing the security of storage account by allowing the communication for the REST API operations using HTTPS. Any request using HTTP will be rejected when we enable the secure transfer option. Microsoft recommends locking all of your storage accounts with an Azure Resource Manager log to prevent accidentally or intentionally deletion of the storage account. We have two types of resource logs: delete, and the second one is the read only. In the delete, you cannot delete the storage account but can read and modify its configuration. And in the read only will prevent from deleting a storage account or modifying its configuration and only permits reading the configuration. So now let's um, go with the demo for the Azure Data Lake Gen2. So I have opened the Azure portal, and to create the storage account, you can search at the search box with the storage account. Click on create. So it will open up the blade for which you can select. First, you need to select your subscription under which you wanted to create your storage account. And you can then create the, or you can use the existing resource group, or you can create the new one. You need to provide the storage account name and the region which is most near to you. So for the performance standard, the most scenario will cover under the standard. So redundancy. So if you remember that I've talked that we get the read access accessible properties for the GRS and the GZRS. So the by default GRS is selected and you will see this checkbox and the similar for the GZRS. So if I go and select the LRS, that checkbox will not longer be here. So So for the demo purpose, we're gonna use the LRS, and we need to uncheck so that people cannot access your blob publicly. And the rest of the properties, we're gonna keep it same. And once you have configured and um, everything for your storage account, you can click and create. So one thing I missed that how to make your storage account as Gen2. So there is a property data lake storage Gen2. So this provides the hierarchical namespace within the storage account. So you need to check box this one. Otherwise, if you don't check this one, then it will create the storage account. It's a normal blob storage account it will create for you. So once you review everything, click and then you can hit create. It will take around 1 minute to finish to finish the deployment. So this is done. Let's go to the resource. So this is the storage account that we have just created it. So under that, we can have containers, and you can create multiple containers underneath this one. And under the container, you can upload the files. So you can create multiple containers, and you can also um, control the access to the storage account using this access control section. So you can provide the access to the different AD groups or to individual AD persons. So under the add role assignment, and you can check the any access for anyone using the search box here. And here at the right hand side, you can see all the configuration that we have set up while creating your storage account, that it's an hierarchical namespace enabled, the hot access tier. By default, we have selected hot and all other details. So this was pretty much about the demo for the Azure Data Lake Gen2. So now let's begin with Azure Data Factory. Azure Data Factory, it's a cloud-based ETL and the data integration services that allows you to create data-driven workflows for orchestrating data movement and transforming data at scale. Using Azure Data Factory, you can create and schedule data-driven workflows called pipelines that can ingest data from many data stores. You can build complex ETL processes that transform data visually with data flows or by using compute services such as HG Inside Hadoop, Azure Databricks, and Azure SQL Database. There are five aspects of the ADF, and it starts with the ingest, that you can ingest the data from multiple sources, and Microsoft provides 90 plus native connectors to connect with the different types of source and the destination. It's serverless and auto scalable, and it's a kind of quick wizard for the copy jobs. Control flow is an orchestration of the pipeline activities that includes chaining activities in a sequence, branching, defining parameters at the pipeline level, and passing arguments while invoking the pipeline on demand or from trigger. It also includes custom-made passing and looping containers, that is for each iterators. Data flow. Data flow are the code-free data transformation that execute in Spark. It can scale out with Azure integration runtime. It's basically a designer for data engineers and the data analyst. You can also build and maintain schedules for your data pipelines. There are different type of triggers that you can create. They are like wall clock, event-based, tumbling windows, or chain. You can also actively monitor your pipeline execution history, and it provides the detailed activity and the data flow execution. You can also establish alerts and the notifications. Azure Data Factory basic flow. Azure Data Factory, this gives the information that how the data factory works. The first thing is that you connect and collect the data. The first step in building an information production system is to connect to all the required sources of data and processing it. The next step is to move the data as needed to the centralized location for subsequent processing. With Data Factory, you can use a copy activity in a data pipeline to move data from both on-premises and cloud source data stores to the centralized data store in the cloud for further analysis. So once you have connected from where you wanted to pull the data, so there comes a transformation of the data. After data is present in a centralized data store in the cloud, processes and transform the collected data by using ADF mapping flows. Data flows enable data engineers to build and maintain data transformation graphs that execute on Spark without needing to understand Spark cluster or Spark programming. Data Factory also offered full support for CI/CD of your data pipeline using Azure DevOps and GitHubs. This allows you to incrementally develop and deliver your ETL processes before publishing the finished product. Once you are done with your transformation of the data, then here comes a publish. After the raw data has been refined into the business ready consumable form, load the data into the Azure Data Warehouse, Azure SQL Database, or the Azure Cosmos DB. The next one is monitor. So after you have successfully built and deployed your data integration pipeline, monitor the schedule activities and pipelines for success and the failure rates. Azure Data Factory has built-in support for pipeline monitoring via Azure Monitor API, PowerShell, Azure Monitor logs, and health panels on the Azure portal. So let's discuss about the key technical concept in the Azure Data Factory. The first one is pipelines. A pipeline in a data factory is a kind of grouping of activities that perform a unit of work. The benefit of is that pipeline allows you to manage the activities as a set instead of managing each one individually. Activities. Activities represent a processing step in a pipeline. For example, you might use a copy activity to copy data from one data store to another data store. Data set represent data structure within the data store, which simply point to or reference the data you want to use in your activities as input or outputs. Link services. They are like the connection strings, which define the connection information that's needed for a data factory to connect to the external resources. Data flows. Create and manage the data transformation logic that you can use to transform any size data. Data Factory will execute your logic on the Spark cluster that spins up and spins down when you need it, and you won't ever have to manage or maintain cluster. Integration runtime. An integration runtime provides a bridge between the activity and the link services. It's referenced by the link service or activity and provides the compute environment where the activity either runs or gets dispatched from. Types of integration runtime in Azure Data Factory. Integration runtime is a compute infrastructure used by the Azure Data Factory to provide the capabilities like data flows run in Azure, run copy activities between cloud data store in public or private networks, dispatch and monitor transformation activities running on the variety of compute services, and execute SQL Server integration services packages in a managed Azure compute environment. So Data Factory offers three types of integration runtimes, and you should choose the type that serves your data integration capabilities and network environment requirements. The three types of integration runtime are Azure Integration Runtime, Self-Hosted Integration Runtime, and the Azure SSIS Integration Runtime. So now let's discuss about what are the key design considerations we should be considering inside our Azure Data Factory. Initial setup considerations. Consider different ADF instances for different environment and setting up a code repository for your data factory. Parallelism management. Given the scalability of the Azure platform, you should utilize the capability wherever possible. In Data Factory, the for each activity is a really simple way to achieve that parallel execution. Managing reusable code. Reusing code is always a great time saver. You can parameterize the link service, the database name in your Azure Data Factory. This reduces the overhead and improves the manageability for your data factories. Enhances security. This allows the data factory to retrieve secrets from key vault using its own managed identity. Monitoring and alerting. Every activity within the data factory has properties like timeout and retry options, setting up the alerts to monitor the failure or success of the pipelines. Following standards. You should enforce the standard for the naming convention for pipeline, dataset, link services, and provide proper description to each activity. Make folders or subfolders to organize the component in the Azure Data Factory. And then miscellaneous covers the documentation. So every data factory should be documented. It should capture the business processes. So what kind of security we get in the Azure Data Factory? Encryption at transit. If the cloud data store supports HTTPS or TLS, all the data transfer between data movement services in Data Factory and the cloud data store are via secure channel HTTPS or TLS. ADF already encrypts data at rest. Data stores support encryption for rest, and Microsoft recommends to enable the mechanism on those stores. Credentials can be stored within the data factory or be referenced by the data factory. It is always stored encrypted on the self-hosted integration runtime. So now let's proceed with the IO Data Factory demo. So let's go to Home. So to create the data factory, you have to search for the data and it will show up certain services. Click Data Factories. Click, and on the screen it will show you whatever the existing ADF you have already built under the subscription you have access. So to create the new data factory, click Create, and we'll open up the blade and first select the subscription under which you want to create your data factory. So you can use the existing data factory. Sorry, you can use the existing resource group, or you can create the new resource group here. So we're gonna use um, the resource group that I have created at the time of storage account, and the name for the storage account. Select the region and the version. So here, as I discussed that under the design consideration that you should configure your data factory with the Azure DevOps or the GitHub. If you don't have the information while creating the data factory, you can checkbox this one, configure Git later, and it will allows you to configure your data factory with that repository later on. But if you have the details, you can enter the details over here. So I don't have the details yet, so I'm gonna check that box and we'll proceed further with all the default selection that we get. So once everything is done, you can review and hit create. Okay, and it's done. So here you can see our Azure Data Factory, and this it gives you provides all the information about your monitoring of the pipelines, the activity runs, what time, how many time it got succeeded or the failed, and if you have configured the trigger, what's the status when the pipeline gets triggered by any trigger, and how much CPU and memory your data flows or your pipeline takes. So you get all that information over here. So to navigate to the Azure Data Factory interface, you need to click on this open Azure Data Factory Studio, and it will open up in a new page like this. So on this main page, you can see that it gives you the option to set up the repository here also. And on this main screen, you can see that it gives us the option to perform the ingestion. And if you have, simply connect and just build the bulk in copy, so you can use the ingest section to do the copy activities. And the orchestrate, I will show you that how it looks like. And the transform data are the data flows that you can make in the Azure Data Factory. And this configure SSIS when you wanted to run and manage your SSI packages in the cloud. So author. So if you click on the orchestrate, it will navigate to the author tab. So here you will see that you have the sections like pipelines where underneath you can build multiple pipelines, and the data set and the data flows underneath here. So if you wanted to create the link services, you need to go to manage, and here is the link services. So you can click on link, click here, and then if you wanted to connect with your Azure Data Lake Gen2, then you need to type search for the data lake storage and select these Azure Data Lake Storage Gen2. So once you hit there, you need to provide the all the details like the subscription for which under which your storage account exists. So once that is done, click create. So you see that we can see the link services. So now it's basically connected with your storage account. So now in your pipeline, when you use these link services, you can use all the files that are, or you can basically connect with all the containers with underneath that storage account. And under the monitor session, it will gives you the here you can see the pipeline activity run. And this is like one of the example through the trigger, which will show my pipeline that runs with the trigger. And if you're just running debugging it without using the trigger, you're gonna see the those pipeline activities underneath the debug. And this is your integration runtime by default we are using. But if you have another self-hosted or US SSIS, you're gonna see it over here. So now let's go to the, I have built two pipelines. Though those are the simple pipeline, just copies the data from one container to the another container. So this is the on this section at the activities, you will see that you have the different type of activities that you can perform in the Azure Data Factory. So move and transform is like copy data, and the data flow underneath you can have the different transformations. And if your source is Azure Data Explorer or destination, you can use this Azure Data Explorer. So we have many activities that you can leverage in the Azure Data Factory. So I've used the copy data, which is under the move and the transform activities section. So what it takes. So for the copy data, it first we need to connect that what source we wanted to copy. So underneath the source data set, I have already connected with this data set. So if I show you, so it's basically using this link service ls ADLS underscore src, and it's navigating to the container raw data, and this is a file, the financial symbol.csv that I wanted to move. So you can just click on preview data to view what kind of data that you're dealing with. And here you can provide that what is the delimiter your file is using. So it we can get comma, semicolon, pipe, tab, and some others. So let's my file using the comma, so I'll keep like that. And the rest of, and also if your file has the first row as header, you need to check this box. So if you go there, so this is the schema that schema of my file. So if you change, if suppose if somebody deleted any column or if somebody added that column and then you have to click to the import schema to refresh the schema. If you don't click on the import schema, then whatever the previous basically from the cache, it's gonna pick all that schema from there, and then your pipeline can get failed. So once the source setting are done, so you can go to the sink where you wanted to move your data. So here I'm using the another I'm using the same link services which connected to my storage account. And under that, I'm using now created named container to move my file. So now you can click validate to see if everything is good. If there is any error, then you're gonna get some errors over here. That if you forget to put any entries that is required for this copy data activity, then you're gonna get there. So once if I click here on the debug, okay, and is done. So now if you remember that we try to move the data from raw data, which is the financial sample CSV file, which is underneath this container raw data, and this is the file. And I wanted to move to the curator. So you will see that file is got moved here with today's state. And the same because I clicked on debug, I didn't run any trigger. So you will see that my pipeline activities, I can see the execution over here. So if I click over here, it tells you how much time everything. I mean, you can. I mean, we don't have much. The other activities. Otherwise, it will give you the proper segregation of all the information. So here you can see that how much data is written, what is read, and how many rows read and how many is copied. So it's pretty much good detailed information that you can get over here. And this is the another view to see how much time it took, how many data, what's the size of the data that it has moved. And I have another pipeline to show you guys. So this also copies the data from one storage account to the another container in the same storage account, but using the trigger. So if I click on trigger here, so first I'll show you that. Oops. So these are the different types of trigger that you can create. So I've already created the storage event type trigger. So what it does, like any time when somebody add any file to the raw data container, and if it's and then what it does, then I'm creating that trigger that on what event it should trigger, like on the blob created or the blob deleted. So I check the blob created. So basically any time when any blobs gets created underneath this container, the trigger will get start. So basically, what this pipeline is taking, I'm using the parameters here, which this is a folder name and the container name, basically the file name, basically what which file we wanted to move or from the folder. This is the container name and the destination container name underneath. We wanted to move the um, files. So in my source now, instead of saying that, hey, move this file, so I'm set the parameters that from this container, so whatever the file set comes, it should pick that file. And underneath the sync section, sync properties, and I have defined the destination name parameter to use from the pipeline destination name. So if I go back here, when I uploaded the file underneath the raw data, um, the the ADF the trigger runs, and you see the entry over here. So I was moving the data from my test folder to the curated folder, and you can see the file is moved here. So this helps to automate the system when you know really don't want to monitor manually your storage account, like for the new files to come up to show, and you want other processes to run. So this is the one way that you can automate your process. So that's it for the your data factory demo. So let's see how the certification path looks like. If you want to earn the certification for the Azure Data Engineer Associate, your certification path starts with one or both optional certifications, which are AZ 900. Those are the Microsoft Azure Fundamentals, and the DP 900, which is Microsoft Azure Data Fundamentals. But the skills required for these certifications is design and implement data storage, design and implement data security, design and develop data processing, monitor and optimize data storage and data processing. So once you are ready by with all these skills, it's time to take the DP203 Azure Engineer Associate exam. So once you pass that exam, you get the Azure Data Engineer Associate badge. How to get started with the Azure account? So to access the services in Azure, you can sign up on the Microsoft website, which gives you a $200 USD credit to use for the first month. After your credit, you move to the pay as you go to keep getting these services. There are 40 plus other services that are free always. And if you are a Visual Studio subscriber, you get Azure credits every month that you can use to explore and try Azure services. So what are the key takeaways? So today we discussed that a different type of data storage and how to create that Azure Data Lake Gen2. How we can implement the security underneath the storage account, and how we can process the lifecycle management for the blobs, and the Azure Data Factory, which is the orchestration tool for data movement, data transformation from various sources. Like you can move the data from on-prem to cloud, or from one cloud to another cloud. So what are the next steps? So I would say, like, first create your free Azure account and prepare for your data engineer certification. And once you're ready for that, take DP203 Azure exam. And you can reach out to your SMEs for any help. So these are some reference link that I have used for my presentation. So now we are at the Q&A. So if you guys have any questions, I will try to answer them. So if there are no more questions, I think we can wind up the session. Thank you for joining it.